Hello, I welcome you all in this presentation related with the subject joining technologies for the metals. In this presentation, I will be talking about basically the two, the solid liquid based joining processes. These are commonly known as soldering and brazing. Related with these two processes, we will be talking about the basic principle of these processes, steps, the materials which are used like the fillers and the fluxes, thereafter comparison between the two like soldering and the brazing, and along with the application of the two processes where these are used. So, as name suggests, these processes fall in category of solid liquid based joining processes. Why are these called so? Because the base metals to be joined are kept in solid state, means they remain in solid state like 1 and solid 2, while the material which is used for developing the joint between these two is brought to the molten state, which is called either braze material or solder as per the kind of the process to be used. So, brazing material or the solder, that is why. So, here in this case heating only heating is involved, there is no fusion of the base metal, and heat which is required for melting the filler metal is also very limited. So, the heat input is low in these processes. So, these are the two very attractive feature, and because of these two only it offers many advantages like absence of the fusion and very low heat input requirements for developing the joint between the two systems, and this benefit is exploited in number of situations. For example, for all those cases where the components like 1 and 2 have the metallurgical incompatibility. So, if after the fusion, if the two forms unfavorable things which lead to the formation of the very poor joint strengths, like if 1 and 2 are fused together and if they are metallurgically incompatible, the kind of joint which is formed is very poor in terms of the strength or ability to sustain the service conditions for long. So, it will not survive, or it may get cracked immediately, it may get damaged immediately as early as the joint is developed. So, this kind of situation wherever the joint is to be made between the two systems or the two components in solid state which are metallurgically incompatible with each other. Another is those metals which have the poor weldability, means they can be fused, but when the joint is made the kind of properties that we obtain are poor, like this. The two components to be joined having the poor weldability, when they are fused either it will result in lot of porosity in the weld or cracks in the weld or in the heat affected zone. Heat affected zone either is very soft end or very much hard end. So, lot of welding related issues are involved in the joining of the metals, such kind of metals using the fusion welding processes, then they will be considered as a poor weldability, and better to join them using the solid liquid based processes like brazing and soldering. Another is odd position welds. Odd position welds, like if the molten metal cannot sustain there during the odd position welding, then it is always good to make the joint using such kind of processes like brazing and soldering, which will allow just the heating of the base metal and melting of the filler metal for developing the joint for developing the joint between the components. Then there is like completely different combination is to be developed, like entirely different combination is to be brought in. For example, like glass and aluminum, or completely any other thing which where the physical and the mechanical characteristics of the two systems are completely different. So, they can be joined together using this brazing and soldering process. Another suitable area wherever the loading conditions during the service as well as the temperature conditions to be experienced by the joint is very limited, very less, there these kind of the joints like shoulder joints and the brazing joints are found to be very useful. So, these are the benefits which are exploited due to the unique feature which is associated with the brazing and soldering, that it involves just heating of the base metals and melting of the filler metal for development of the joint. Limited heat input ensures that metallurgically incompatible poor weldability metals can be joined effectively for development of the joint. As far as the process principle is concerned and the process is concerned, here what we will do, the components, mainly the two types of the joints are made. The most common one is the lap joint configuration, and sometimes even butt joint can be made for those cases, but for making the butt joint sometimes beveling is especially tried so that the required joint strength can be achieved. As far as the lap joint is concerned, the plates or the sheets to be joined are kept in lap joint configuration, and a particular gap between the plates and the sheets to be joined is maintained, which is called clearance. This clearance plays a very big role for successful brazing and soldering, and this is kept like 0.075 to 0.125 mm. Because this gap ensures that whenever the brazing or soldering material is brought to the molten state by the application of external heat, this molten solder or brazing material will be sucked inside the gap between the fang surfaces of the component to be joined and by the capillary action. So, capillary action will be effective only if the two conditions are there, the molten filler is very thin, of less viscosity, one, and the fang surfaces means the surfaces of the component being joined are very clean, fang surfaces are clean enough. So, these must be, the surfaces must be free from impurities like dust, dirt, oil, grease, etc. So, proper cleaning is needed of the surfaces to be joined, and the gap is maintained. Once the plates prepared properly, proper gap is maintained, heat is applied. Once it has become hot, the filler metal is applied. Filler metal, either brazing or soldering material will be brought to the molten state. So, it will be sucked in by the capillary action between the components. it will be sucked only if it is thin enough and less viscous and having very clean surfaces, if the proper gap is maintained. So, gap, thinness of the material as well as proper cleaning of the film surface are very crucial for uniform distribution of both shoulder as well as brazing material. If it gets uniformly distributed, then the proper joint strength is achieved. If it is left some of the places, then that area will be left unjoined and the joint strength will be poor in that case. So, proper surface preparation is very crucial for developing the good weld joints. So, here as far as the steps are concerned, first the surface preparation with the proper cleaning preparation. The second is the placement with the proper gap. Third is application of the heat, then the filler and is brought to the molten state, melting, and then the distribution by the capillary action, and followed by the solidification. Once the solidification is completed, the joint is prepared or joint is ready. But we know that despite of the proper cleaning, some of the impurities are left at the surfaces, the molten filler will be able to interact with the gases in air or like impurities present on the surface. So, these two things must be taken care of properly, and for that purpose the impurities and the kind of compounds which are formed by reaction between the filler and the atmospheric gases, like in form of oxides, the fluxes are used. So, fluxes are also applied or placed beforehand when the filler metal is placed, so that the flux also melts along with the filler metal and it works effectively in number of ways. So, the application of the flux namely maybe in form of like paste, powders which is applied, and then this flux after melting does number of things, like it lowers the surface tension of the filler metal, it avoids the oxidation of the filler, and so surface tension is reduced. It helps in making the means improves the capillary action in better distribution, and the flux also interacts with the impurities to form slag. So, formation of slag by reaction with the impurities. So, flux will be reacting with the impurities and the slag. Flux will be reacting with the impurities to form slag, and this slag being lighter is removed from the surface. So, this is about the butt joint configuration. We know that this is about the lap joint configuration, and we know that if the butt joint is to be made for a particular application, then for that purpose different some special arrangement must be made in order to achieve the desired joint strength. And for that, say if this is the sheet to be joined in simple butt joint configuration, this area will be very less in order to offer the joint strength. So, in such situation normally beveling of the surfaces is carried out. So, the surface area increases and then we will see that the filler is placed between these between the fixed surfaces for developing the brace or shoulder joints. Alternatively, another kind of configuration of this kind also can be made, wherein the opposite corresponding surface will be like this, and between these we can place the brace or the filler joint. So, these are the butt joint configuration will be able to carry the tensile load as well. So, in order to increase the joint area, the beveling or special or single or double beveling arrangements can be made in order to increase the joint area, so that the load carrying capacity of the joint can be increased. Now, there are various points based on which we can compare bracing as well as shoulder joints. For example, shoulder joints or shoulders, soldering is performed, like say this is for soldering. Obviously, the shoulder mainly the lead and tin based alloy is used, and for the bracing purpose like alloys of copper, aluminum and nickel systems are used. They offer somewhat these systems melt at a higher temperature, say 450 to 800 degrees centigrade, and this one is used for the lower temperature conditions like 187 to the 275 degrees centigrade. So, the lead and tin are the low temperature systems, and means the shoulders, this is called solder. Low temperature systems melts at very low temperature, these melt at very high temperature. So, for the bracing purpose we definitely need higher heat input as compared to the soldering, which requires low heat input because of the difference in the melting point. And since the shoulders they have the low melting point, so these offer very low strength as well as the low temperature tolerance capability, means they cannot work at a higher temperature. With the increase in higher temperature they get soft and strength is reduced, so the joint load carrying capability is very adversely affected. So, these are good for very low light load service conditions at low temperature, and these are good enough for the means high, they offer high strength and reasonably moderate temperature service conditions, under which these can work. So, these are used for like say developing the joints for the tubes or like carbide brazed tools, and these are mainly used for the electronic applications where the loading conditions, where the joint is primarily made for the flow of current, not for the load carrying capacity, not for increasing not for carrying the load. So, the shoulders are primarily used for the electronic applications, while the bracing joints are used where moderately higher load carrying capacity is required, or the higher service temperature conditions also can be sustained by the bracing joints. So, these are the kind of some comparison points. Apart from this, we will see that the different points on which these can be compared is these are the heat source. So, that is it. So, based on the heat source requirement, very light heat source like soldering iron is sufficient for this purpose, because very limited heat is required for developing the weld joints, but very high heat is needed for the larger amount of heat is needed for the brazing purpose. So, we need the special sources of heat, maybe like the gas flame or induction brazing. There are various brazing methods. So, these brazing methods basically for the brazing there are various ways by which heat can be applied at the fin surfaces, so that the brazing material can be brought to the molten state. Similarly, the different sources of the heat can be used for the soldering purpose, and according to the method being used for application of the heat, either for brazing or soldering, the methods are described accordingly. Like some of the methods I will be talking here, along with the filler materials which are used for the brazing as well as soldering. Now, we will see here, in addition to this comparison, there are certain negatives also related with these processes, and the negative aspects related with the brazing and the soldering primarily includes from the inherent feature related with these two processes. So, the limitation one includes that the strength, if you see, the base metals are kept intact in the solid state while the filler is brought to the molten state. So, the strength of the joint, so the joint strength is lower, always lower than the base than the base metal. So, the limited strength is one weakness of the brazing and soldering process. Another is they cannot sustain the higher temperatures, likes, so good for moderate and low temperature conditions only. They cannot sustain the higher temperature. Sometimes the brazing and filler material, the solder and the brazing materials becomes of the different colors. So, the color mismatch in the braze and solder joint is another problem, because it adversely affects the steam value of the joint, and sometimes the dissimilar metals promotes the corrosion. Additionally, it becomes important for cleaning of all fluxes whatever has been used. So, the flux cleaning, like the fluxes like borax and boric acid are commonly used, the fluxes, and these must be cleaned after the soldering or the brazing, so that if these are not cleaned properly after the soldering, then because of their corrosive in nature, these fluxes are corrosive in nature. So, they will be promoting the corrosion of the joints as well as of the base metal. So, it is important that the fluxes after the application are cleaned and removed properly after developing the joint. Now, we will see some of the specific metal systems which are used for developing the weld joints, as well as the kind of the arrangements which are which is used for, like for the brazing and soldering purpose, the plates are kept like this with a certain gap and the heat source is applied, and thereafter the flux and the filler is placed. Once it is brought to the molten state, the filler spreads between the fin surfaces, and after the solidification it results in the joint, formation of the joint. So, the clearance is extremely important for having the capillary action in order to ensure the uniform distribution of the filler material between the fin surfaces. Preparation of the plates is important to make it free from the impurities, so that proper capillary action can be ensured, and for making the butt joints, some edge preparation is important in order to increase the contact area between the plates to be joined, so that the joint can be made of the sufficient strength. These are the different points based on which brazing and soldering can be compared, like melting point of filler, it is lower for the soldering and then the brazing. Strength of the braze joint is much higher than that of the shoulder joints, and ability to withstand high temperature is good for the brazing as compared to the soldering, better for the brazing joints as compared to the soldering joints. And heat source requirement means more high capacity heat source is needed for the brazing purpose as compared to soldering purpose, and according to their load carrying capacity or ability to sustain the higher temperature, these find different these two processes find applications in the different areas. So, this is just the comparison purpose. Limitation of these processes, these are poor in strength, inability to withstand high temperature, and sometimes color mismatch is also another problem which is encountered. These are the kind of the materials which are used for the brazing purpose, brazing temperature and corresponding filler materials which are used. Like for the nickel copper systems, it is 1120 degree centigrade, stainless steel and nickel systems are brazed, and AU and AG system 950 is the temperature of brazing, and stainless steel and nickel systems are brazed, like steel and cast iron, copper zinc systems, copper phosphorus for copper systems, copper for nickel and copper systems, aluminum silicon for aluminum systems. These are the different purposes for which fluxes are used. It takes care of the surface contaminants, oxides, oil greases, oxidation of the base metal, oxidation of the filler and fluidity of the molten metal. So, all the oxidation and the grease and oxides and contaminants are taken care of, while the fluidity is improved by the filler. The fluxes helps to dissolve the oxides from the fin surfaces, reduce surface tension in order to improve the fluidity, and these protect the base metal and the molten metal filler from the oxidation during the joining operation. The common fluxes which are used are borax, boric acid, and these are the fluxes commonly used with the brazing, for the brazing purpose with the copper fillers, and these fluxes can be used in the form of pastes or the solutions or the powders, they can be applied over the surface. So, now here I will conclude the presentation. In this presentation, basically I have talked the basic principle of the solid liquid based processes like brazing and soldering, and the conditions under which these processes can be used effectively, the basic principle of these related with these processes, and the kind of material systems which are used for the brazing operations. Thank you for your attention.